All right, guys, how does fluid power work? First, we're gonna talk a little bit about Pascal's law, and let's say you have a box over here. Let's say we have a box, and this is a sealed box. There's no exit, no escape out of this box, right? And let's say you have a confined fluid. There's a box over here, and there's fluid in here inside this box. And over here on top, you have a cover that you can move up and down. Let's say you can move that cover, and you're gonna apply a force on that cover. And so you're gonna apply 10 pounds of force on this one, and you're gonna compress this fluid that is inside this box. When you apply those 10 pounds in here, all those 10 pounds go and they get applied all around the walls of this box. On all the sides of this box, there's 10 pounds. The same force that you apply on top, the same force it is applied on all direction of this box. That is basically Pascal's law. Physics. I'm not a physicist, but that's the principle of the law. So on a hydraulic system, another way to look at it, let's say you have a container. Let's say you have a big container over here. And on this side of the container, you have a small cylinder. And on this other side of the container, you have a bigger cylinder. All of this is full of liquid again. All of this has liquid, compressed fluid. Not compressed fluid, but fluid without escape, enclosed fluid in there. Let's say this area over here is 1 inch square. The area, not the diameter, but the area is 1 inch square. 1 inch square. And this area over here, let's make it 4 inch square. And you're going to apply 10 pounds of force on this direction over here. 10 pounds over 1 inch square. Basically, that is 10 pounds per square inch. 10 psi of pressure that you're applying on this side of the container. Now, all of this is fluid. That same 10 pounds is going to apply in all directions inside this box. And over here, you have also a bigger area. And now, on this area, you want to lift a load on this side. Oh, big question. What do you think you can lift over here, right? So you have 10 pounds of pressure applied into 1 inch. This is 4 inches. 4 square inches is 4 times the area. You are going to be able to lift 40 pounds on this side. You're going to be able to lift 40 pounds of force on this other side of the container by applying only 10 pounds of force on this side. That's how you multiply the hydraulic power. That's how you multiply. You transfer. You can say you multiply. You can say you transfer power. Now the difference between one and the other one is going to be you multiply the force. You multiply the how much weight you can lift, but you're going to lift it at a lower speed. So if you're only moving, let's say, 40 inches this direction, you're only going to be able to lift it 10 inches in the other direction. Or at least on the speed, because the speed on how fast you move it down it's going to reduce it by 4 times the speed on the other direction. So you lift more but at a lower speed. So that's basically how hydraulic works. That's basically what fluid power, how fluid power works. Another way to look at it, you have on this side, you have a hydraulic pump. Yeah, let's say that's your hydraulic pump over here. And let's say on this side, you have a hydraulic cylinder. Right? And over here, you have a load that you need to move. So this load, 40 pounds, is right this thing over here. This cylinder, this area right here is this cylinder right here. And this 10 pounds over here is this pump over here. And now you can apply pressure, you can apply flow, you can vary the size of the cylinder. You can put a bigger or smaller cylinder. And the pump is going to give you X amount of pressure, X amount of GPM. You know, you have PSI, you have GPM, gallons per minute. And depending on the pressure, the GPM that this pump is able to supply to move the resistance, the weight that is required to be moved, you're going to have the horsepower that is going to be required to pump oil on this system over here. This is the couple of an electric motor. This is the suction of the pump. That's the cylinder, and this is the load. So if you need 40 pounds over here, you're only gonna need 10 psi. And depending on the GPM that you're gonna put in there, how fast you're gonna move it, GPM times PSI is gonna give you a certain amount of horsepower that you're gonna use on your electric motor to be able to move this load over here. And if you have if you have 1,000 pounds, if you have 10,000 pounds, you may need a bigger cylinder, bigger area, bigger PSI, a higher PSI. And depending on the speed that you're going to move it, you're going to need a higher GPM for the pump. So, and the bigger your load gets, the bigger your hydraulic requirements on moving a load that is bigger and faster. It's going to require bigger pressure, bigger GPM, and therefore it's going to give you a higher horsepower requirements. So, but this basically is how a hydraulic system works, how a fluid power system works. It's just compressed fluid that you need to apply pressure into that compressed fluid to move a load. And from there, you just do some engineering and figure out the sizes, the dimensions of the cylinders, and the dimensions of the pump, and therefore, and from there, that's how you are able to move a load and do whatever that you need to do, right? And this is this type of system over here is the one that is needed in a lot of machinery, construction machinery, mining equipment, industrial plastic injection, and a lot of application that requires to move a heavy load. So that's basically how fluid power works. And hopefully you like this video, and make sure to subscribe. If anything you need on industrial products, feel free to contact me. Website above. We'll see you next time. Bye bye.